Cameron, my friend, can you read to me that word right there? That's why I was insistent that you have a calculator. This is the applied math part, and I love this applied math part of the physics. I hate the way the provincial exam and the textbook goes about explaining these equations. I will try and make them as clear as possible, but I'll be honest, Ryland, if I was trying to set up a situation to make this look intimidating and confusing, I'd probably give you this here equation sheet with all the triangles. I think it's stupid. But it's what you're going to get, so I'll prepare you for it as best I can. But you're going to hear me, Allison, go on the occasional rant like I am right now on YouTube. Sue me, government. Okay. Yeah, I know. And I just realized. So after my rant, I forgot to print up my old copy of the notes. The acceleration of an object, the textbook wants me to tell you, is dependent on the, now I'm going to say out loud, change in velocity, but can you think of a way that I can write that with 2 characters instead of writing out the word change and in and velocity? Yeah. So depends on this, and I'll put the arrow, the vector bar, just change in velocity, not speed. And now I'm going to write change in time, although we get sloppy. Time is always a change in, and so you're often going to see that I don't bother writing the delta. The acceleration of an object depends on 2 things, the change in velocity, how big it is, and the amount of time required to change that velocity. Remember yesterday I showed you the picture of the old car and the dragster. They both had the same change in velocity because they were both going from 0 to 100, but we agreed because the dragster was doing it way faster at less time, it would have a bigger acceleration. So you can either have a different change in velocity, or you can have a different amount of time, or both, but that all affects the acceleration. When stopping a moving object, the relationship between how long it takes and acceleration is, if it takes longer to stop, that's because you weren't speed up, it's because you weren't speeding up or slowing down as fast. Your acceleration is smaller. Ryland, here's what that's saying. If you have a small acceleration, it's going to take you way longer to get to freeway speed than if you floor it. All flooring it is doing is reducing the amount of time in our equation. Make sense? Oh, also, if you decrease the stopping time, that's going to, there's flooring it. So, or to stop hitting the brake. I guess, you know what, since we're talking about stopping, I guess this would be hitting the brakes really hard. And this would be tapping the brakes. Because, Alex, if you start on the freeway, 100 kilometers per hour, and you come to a stop, your change in speed, your change in velocity is the same. So what's the acceleration? Depends how fast you hit the brakes. That's why, in fact, the change in acceleration, the change in velocity in a car accident is the same as the change in velocity when you pull over safely. You're both going from 100 to 0. Why is a car accident so much more dangerous? Why is a car accident so much worse? Yeah, less time. By the way, it's not the change in velocity that kills you, it's the acceleration. Did I give you the notes, Dylan? Yeah, I did? Okay. So, this relationship of acceleration, change in velocity, and change in time is given by these. It's given by these. Your purple sheet, but you have it in your notes here. We've been using these ones already. We're really going to start to use this one here, except this one here, draw an arrow and point to that. I don't even think A equals delta V over delta T. I think A equals VF minus VI over T. And that's a Physics 11 equation that we flogged to death. And in fact, that's how I give it to my Physics 11 students. None of this delta triangle garbage stuff. Let's crunch some numbers. A pool ball is traveling 2.5 meters per second towards the cushion, and it bounces off backwards at 1.5 meters per second. If the ball was in contact with the cushion for 0.2 seconds, what's the ball's acceleration? And let's assume towards the cushion is in the positive direction. Matt, now that you're done yawning, what's this question asking me to find? You can pull it off. What's this question asking me to find, kiddo? Read. It's after the word, starting with the sentence if. In fact, start reading right here, my friend. From the word what? Ah! With a big, strong voice. I caught you mid-yawn. That was my fault. What's this question asking you to find? I'm going to use my DFIC approach. I'm going to go A equals question mark because I feel better. But also, what that's just done, Julia, is that's targeted me on this one here. Maybe this one here, but here the A is not by itself, so I'm kind of going to... I'm looking at the equation that's got the A by itself. What else have they told me? What's this 2.5? What are the units right next to it? Now, if it was acceleration, it would be meters per second squared. Is it meters per second squared? No. What do I measure in meters per second? Time? No. It's a velocity. Now I have to read, Julia, is this my starting initial or my ending final velocity? What do you think? Looking at this question, is this your initial velocity or your final velocity? So I'm going to write down and I'm going to put a little positive because in brackets it said assume towards the cushion is positive. Now, if you don't put the positive, I'll assume it's there. Really, in my homework tie, I'll only put the negatives in. But in my notes, just to remind me that I did ask that question, that's positive. Keep reading. Joseph, what's the next number you see?
1.5 meters per second.
What's that 1.5? Time? Say no.
No.
Acceleration? Say no.
No.
What do I measure in meters per second? Cam, is that my starting initial or my final velocity? Okay, and he's wrong technically. I'm going to write this. Oh, Taylor, what?
Negative.
What word told you negative? Backwards. Catch that? Yes? Keep reading. I'm looking for numbers. Blah, 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 blah. 0.2. What's that? Time. I told you I hardly ever write the delta. I know it's there. I'm just lazy. Matt, I'm coming back to you. What did you say we're trying to find? So the equation is this. Don't write this down. Don't write this down. Don't write this down. Except I've told you I don't even bother going there. What is change in velocity? Now I realize there's a change in velocity here. Don't use that one. Use this one. They're across from each other. They go together. What can I write instead of change in velocity? Or, as I've said, what's change in anything? Write this down. A equals V final minus V initial over T. If you can, Sage, get this far, the rest is plug and chug. Coming back to you again, Matt. Looking at what we've listed, what did we say the final velocity was in my little list there? What did I say the final velocity was in my little, up here, what did I say V final was? Now it's plug and chug. Negative 1.5 take away. What did I say V initial was? 2.5 over. What did I say time was? Now, I want all of you to get your calculators out, because if you have a good scientific calculator, you're going to have to put the top in brackets because there's more than one number. If you have a cheap foot-shaped calculator, you'll have to type the top, press equals, and then divide by the bottom. What is the acceleration? So on my calculator, it's going to look like this. Bracket negative 1.5 minus 2.5 divided by 0.2. And if you got a good calculator, great. You don't need one, but it helps. And I'm getting an acceleration of, what's the negative telling you? You accelerated in the opposite direction that you started traveling. You were traveling forwards, you accelerated direction. You're traveling forwards initially. Which way did you accelerate? What's the negative telling you? You were started out traveling forwards. Your initial velocity was forwards. What does the negative tell you? What direction is your acceleration? I'm looking for one word. Backwards. Backwards. You slowed down, and you also got a boost backwards. This was a pretty big acceleration. By the way, negative 20, that's about 2 Gs. So if you said negative 20, Alex, I'd take that. Or you could say (20 meters per second squared) backwards. Which one's less writing? You know what? A negative is worth 1,000 words sometimes. I'll use the negative. Okay. And what I'm saying to you, Joseph, is with these equations, I can give you any three of these four things, and you can find the fourth. I can tell you my initial velocity, my final velocity, how long it took, and you can say, oh, I know what you're accelerating at. I can tell you my acceleration, my initial velocity for how long I accelerated, and you can say, I know what your final velocity is. I can give you, Ty, your final velocity, what you accelerated at, how long, you say, I know how fast you were when you started. Or I can tell you, I have this acceleration, I'm starting out this fast, I want to end up this fast, how long do I need to press the gas? I can tell that too. Read number 2 to yourself. And I picked on Matt, so now I'm going to pick on Matt because he was yawning. Read number 2 to your example 2. What to yourself? And I'm going to say to you, Matt, what are they asking us to find? Which one, at the start or at the initial or final? How did you figure out so easily final? What was the word? Begins and end. Okay, so you want to look for words like begins, starts. Those are initials. Ends, finishes. Those are final. Later, that's a final. So what do you say they're asking me to find? Allison, I always write down VF equals question mark. Now, technically, because it's a velocity, I should have vector signs on. Taylor, you'll notice in the previous one, I was sloppy. There technically should have been a vector there. But here's my point. I got the right answer anyways. I won't take marks off. I'm just going to be fussy and emphasize doing it the right way, purely, Jaden, because I'm a nerd. Okay. Matt, let's start at the beginning. All of us right now, we're going to underline 2 words. These are 2 very important physics words. This right here. Can you underline that? What does that tell me? What's 0? What's starting at 0? Time, acceleration, or velocity? Yes. Which is, by the way, makes the question easier, because what's the easiest number to do math with? 0, even easier than 1. Is that okay? Keep reading, looking for numbers and units. What's the next thing I see? 3. What's that, Matt? What are the units next to it, Matt? What do I measure in meters per second squared? I measure distance in meters per second squared? Accelerate. Okay, so part of your job, you need to do enough of the homework so that you memorize what units go with what. Because if you do that, it really is almost jigsaw puzzle filling in the blanks. What's meters per second squared, Joseph?
Sorry.
What's meters per second squared, Matt? Keep yawning. Keep reading. What's the next number we run into?
5 seconds.
Oh, what's that? Okay. Allison, you okay with the setup? Yeah. You're not foolishly typing on your phone or anything like that? No, of course not. Matt, what did you say we're asked to find?
Time.
So, really? We're asked to find time?
Velocity.
Which one?
Final.
Okay. Is there an equation that has a v final by itself? That one. Ty, I'm going to write that down. And Julia, did I already mention, you don't have a headphone in your ear or anything foolish like that, do you? Is that a headphone in your ear? Oh, I thought I see something. Is it your hair? I apologize. I took your phone. Oh, that was smart of me. Julia, you may recall I went on a rant at the beginning about how I would never teach this, and this is why I would never teach this way. This is a stupid way, yes, I'm calling out the science textbook, to teach this. Julia, what is that right there? What two things? Just read it to me. What shape? Triangle. What do we? How do we pronounce that in science-y? Delta. What letter? What shape? Delta. I would never have given you two different expressions for the same thing. What's right there? Julia, my joy? Okay. In your notes, I want you to go like this. And you can't do this on your formula sheet because on the provincial, it won't come that way. In your notes, from this delta V, point there, point there. In other words, Conlon, if I'm using any of these two equations that have a delta V, don't use this one. Use this one. Which is what? Ty, can you read this to me? Change in velocity equals what? Thank you. Times. See down here? Now, I'm going to write this in our notes, but I'm going to put an equal sign, and I'm going to say I would never stop there. It's VI plus AT. What happened to the change in front of the time? I told you I drop it often because I'm lazy. Oh, and that's an A. You ready, Matt? Coming back to you. What did you tell me, Matt, the initial velocity was? Look at our data that we listed. So, VI 0 plus. What did you tell me the acceleration was? What did you tell me the time was? The change. Yeah, I know it's a change in. Anyways, the time.
5.
In your head, Matt, what's 0 plus 3 times 5?
8.
Times. Positive or negative? So forwards. Okay. Velocity. What are the units for velocity? And if I haven't said so, it's worth saying you need to memorize. It'll cut down on your errors. What units go with what? What are the units? Now, Matt, I can see you pondering. Look up. I'll show you a dumb way to figure it out, a clever way to figure it out. Over here where we define things, what's that right there? Velocity. It's distance. Meters over time. Seconds. It's meters over second. Meters per second. So the units are kind of hidden in there. Okay. Next page. I have to laugh because I saw this on your notes. Allie G, my joy. Ready? I'm going to throw this one out, first of all, just to the group. Read this question to yourself. Take a guess on your notes. No one else is going to know. Write down what you think this question is asking you to find. In other words, go and read to yourself. Do you think it's asking you to find acceleration, time, initial velocity, or final velocity? Read. Take your guess. What do you think it's asking you to find? Okay. Now, if you're not sure, Sage, look up. Ready? It's not asking me to find acceleration, because that's accelerate. And Matt, this goes back to me picking on you about why it's worth knowing what units go with what units. I see meters per second squared. They gave me the acceleration, so I scratched that off. That's a velocity right there. How do I know? Meters per second. That's a velocity right there. How do I know? Meters per second. So they gave me two velocities. Sage, can you read those two words to me?
How long?
How long? What's that asking me to find? You okay with that, Ollie? Thumbs up? Yeah. So now we're going to look for numbers. Or the word stopped or at rest, because that means a 0. Read. Ooh, what's this? What are the units? Read that to me. What is meters per second, folks? Is this your starting or your initial or your final velocity? Nice. Keep going, keep reading. I see 22 meters per second. Now we should be cautious in direction. Allison, the first velocity, what was the direction? And it says east is what? Okay. What's this 22? East, so positive. What is it? Time, acceleration, or what are the units? Which means is this initial or final? Well, since we have initial already and this is later, what are you going to say? Final. Nice. Keep going, Allison. What's that 0.5? Here's your hint. Yep. Also meters per second squared, and the fact that they said accelerated. East or west, according to this question, what's the acceleration? So positive. Tell me on the previous page or on your purple sheet, please tell me we have a time by itself somewhere that's got acceleration and other stuff in it. Do we? Right here. Yes? Now, which delta V do they want me to use? Well, I'm going to give you a hint. Alex, here's how you can kind of figure it out. What are they asking me to find here? Time? I don't want to put time on this side because I don't know time. Taylor said, hey, Mr. Dueck, that also goes with that one. You can draw that in your notes. Sadly, not on your formula sheet, but in your notes. So, Sage, the equation I'm going to use is this. The change in time, oh, for Pete's sakes, I get lazy and I stop writing the delta. The change in time, now it wants me to write, don't write this down. But what can I write instead of change in velocity from the top right corner? Because change in anything is final minus initial. If you had a good physics teacher, he might have tried to give you that little hint so you could actually do that intuitively. Hey, Allison, we've got the correct equation. Now it's plug and chug. So read to me, my joy. What did you say V final was? And then there's a minus sign. What did you say V initial was? 14 divided by, what did you say the acceleration was? 0.5. Always be careful. Make sure you read. Last thing you want to do is read your own writing wrong, right? Call that a transcription error. Is there more than one number on the top of this fraction? If you're going to a graphing or a nice calculator, you should put that in brackets. Or, I mean, you could always go 22, take away 14 in your head. 8 divided by 0.5. Anyways, what do you get? I think 16? Positive or negative? Okay. Time should always be positive because it's a scalar. Well, Einstein said you could go backward. No, actually, he said you can't go backwards in time. You can't have negative time. 16, final. 16 what, Allison? What do we measure time in? Meters per second is velocity. What do we measure time in? If you're not sure, look at the previous page at some of the questions. So find where we labeled time, find the number, find the units next to it. Psst, look up. What did we say time was here? 5? Find the 5. What are the units next to it? I measure time in seconds, kiddo. Okay? I'll leave you alone now. But you still pay attention. Matt, this way. Matt, she can do better. This way. Trust me, she can do better, so you're out of luck. On your own, read number 4 to yourself. Figure out what they're asking you to find. By the way, it's usually the last sentence. So all of us, we're going to write down A equals question mark. Now, eventually, if you get good at this, I'll let you not do this method. But for those of you that are struggling, this is a systematic method. Ty, you with me? You look like you were zoning out. Okay? What 2 words should I make note of? From rest. What's that telling me? You might want to underline the word from rest. Is that my initial speed, velocity, or my final velocity? Okay. How do you know? Because what word is in front of that? Starting. What's that 18? What final? V final? What's that 4.5? How do you know? Seconds. Is there an equation that has the A by itself? It's an optical illusion, Matt, but I need your focus here. The pen is still solid. Okay? You got this written down? A equals... Now, I could write this, except I've told you I don't even like writing that because what's changing anything? What's the delta V that I need to use there? (18) minus 0 divided by what's the answer? Direction. First of all, units. Okay. Now, you could say this. Taylor muttered -4. You know what? There's nothing that says west has to be negative, but I would probably be okay with that. But then technically you should have made this velocity negative as well because it's west. Oh, you did? Nice. But it's not a... Hey, which way is west for you guys? Yeah, that was west for in terms of facing the screen. That can be positive if it's mathematically convenient. In fact, in Physics 12, we'll often let positive be whichever gives us the easiest math. If down gives us easier math to be positive, we'll do that because what we want to avoid is the whole minus making the anyways. Try number 5 on your own. I'm going to do it up here. Race ahead if you want. And it wants a velocity, which means we need magnitude and direction. Yo.
So, I think these questions,
Yep.
I don't even really have to look at the formulas to do it. Like, it's all just...
Intuitive? Means A, you've got a good physics sense, and hopefully it means I've done my job okay.
No, but are these like as hard as they get kind of thing?
Well, when we start looking at free fall and acceleration, because the universe doesn't have this nice numbers, It's you're gonna have to do a bit more arithmetic and math, and it can get tougher, but probably not in Science 10. I heard a phone. Keep an ear out. I heard a phone. If you guys catch who it is, let me know.
My phone is on.
It came from over this way.
Probably the ones, yeah.
I powered them off, I think.
Mine's probably not mine, but- If it's on the there, it's your fault.
Pardon me?
If it's on that's in there, it's your fault.
Oh, you think so? I want one that's got VF by itself. Is that okay, Courtney? The equation says this. But which delta V am I going to use here? I'm going to use... Boy, it's missing. Let me pause. Is that okay? I don't know if I got you guys or if I'm losing you or if you're finding this straightforward, but... Pardon me? You lost? Okay. So you okay with we figured out when it says what is the toboggan's velocity at the end, it's asking for V final. Then you go back and you're looking for, what's that 5? It's meters per second. It's moving. That's my initial velocity. Accelerates backwards, negative. Now, if they hadn't put the negative there, I would have put one there anyways because it did say backwards, but they were nice. They said, oh, negative. Meters per second squared, it's an acceleration. There's time. Okay? Now, I got to go to the previous page because it wants me to find V final. This one. You okay with that so far? Problem is, I'm not a big fan of... Let's undo that, Mr. Dueck. I don't like this. Which change in velocity do they want me to use? For this equation, they want me to use AT, not final minus initial. So, you ready? I wrote this down. And then I said, oh, but for that, they want me to use... Is that okay? Keep going, Matt. What's VI? Now it's fill in the blank. What's VI? What's VI? Don't overcomplicate it. 5 plus, what's A? Minus 0.4. What's T? What do you get? No Timbits for that. Sorry, guys. So what is 5 plus negative 0.4 times 10? Now, if you have a good scientific calculator, you can type this in as is. If you've got a cheap foot, you have to do bed mass. You have to do the times first and then do all that stuff, right? Do you get 1? Is the answer 1? Yeah? Positive or negative? Units, it's velocity. Direction, positive or forwards. You know what? I'll just put a plus there to emphasize that it's positive. Yep.
Can you multiply the time by the acceleration and subtract it from the velocity?
That's what I did. That's how I did it in my head. Because I'm good at my 10 times table, even with decimals. Yep. Okay. I'm going to pass 6. I'm going to do 7. Because I think you guys are getting the hang of this. This is a stupid question. And I'm only doing it because it shows up in the textbook homework. Suppose our what? Okay. So now change in velocity is negative 90 kilometers per hour. And it took, what's that 5? Time? What's this want me to find? What's the equation that has the A by itself?
V over T.
Got to be fussy. It's not quite V over T.
Delta T.
Change in V. You know what? They gave me delta V. It's negative 90. And this is in hours, but this is in hours, so I don't need to do any conversions. I'm okay with this. I'm going to get whatever the heck negative 90 divided by 5 is. Negative 18. What? This one is going to be kilometers per hour squared. Here's my problem. I have a tough time imagining anybody over a 5-hour period slowing down, having a change in velocity of 90 and wanting to know their acceleration. That's like saying every hour they slowed down by 18 kilometers per hour. I can't think of a situation like this. This is a stupid question. I mean, the math works. The physics doesn't. Gravity. Free fall. Now I can answer your question, Alex. It gets a bit more interesting. When you drop an object like this, it accelerates. By the way, if I drop something right now, what's my initial velocity? Think about it. Right now, if they say the word dropped, you can assume VI is 0. They're not going to tell you that, Allison. If you're dropping something, VI is 0. What direction is my acceleration? Down. What would be a good way to show that? Negative. Yes?
Can you define gravity when it bounces back up?
Nope. It's a change in energy. It's conservation of energy, physics 11. Ask me that question another time when I have more time, or towards the end of class when I want to distract you. Squirrel! Okay, here we go. Objects near the Earth fall to the ground due to the force of gravity. Gravity is an attractive force. And it turns out, Alex, gravity acts all throughout the universe between any two or more masses. Any objects that possess mass have a force of gravity. It's just gravity is really, 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 really small. Here's what that means. Allison, can you look at Matt, please? Matt, can you look Allison in the eyes? Both of you have a mass in kilograms. It is undisputable that both of you are attracted to each other. Look into each other's eyes. Matt, I'd like you to say, Allison, I'm attracted to you. Hang on. We can do better than this. However, the faster you fall, there's something like air resistance. Air resistance is a friction-like force. And it opposes the motion of objects through the air. If you're ever sitting beside the window of a car and you're not on the freeway and you're not driving, stick your hand out the window with your palm flat and experience the air resistance. You can turn your hand into a wing and you can do that. It's great physics. You'll find air resistance is biggest when most of your area is facing the direction you're traveling, your cross-sectional area, and it's smallest right here. When I jumped out of an airplane, eventually I jumped out of an airplane, I had a small air resistance. All the parachute does, Andrea, is that. Same thing, you guys. I'm sure all of you at least once have stuck your hand out the window, and it's good physics. Just do it safely, preferably on the outside of the road, not towards the middle of the road with cars coming the other way. However, air resistance is very difficult, Taylor. You need calculus to deal with it well. So, if we ignore air resistance, all objects will accelerate to the Earth at the same rate. I showed you a video the other day of a bowling ball and feathers in a vacuum. And what did we notice? They fell at the same rate. Yes, with air resistance, the feathers, I'll get you a second, will flutter down. But in a vacuum, they both went crashing down. Yes? Quickly, buddy. The acceleration due to gravity. We use a little g for acceleration due to gravity. Why would we use a little g for the acceleration due to gravity? G for gravity. It equals y meters per second squared. It's an acceleration. Why negative? When you drop something, what direction do you accelerate? What would be a good way to indicate down if we don't want to write the word down every time? Sure, negative. Okay. If I do this, toss something up and catch it, this is the velocity versus time graph. And this is very counterintuitive to people. So let's talk about this. Right when it leaves my hand, ready? You guys look up. Right the split second it leaves my hand, when it's right there, what direction is it traveling? How could I show up on a graph, positive or negative? Is it traveling at its fastest or at its slowest when it just leaves my hand? That's why we start out positive, going up and up high. This is a velocity time graph. As it goes up, Courtney, on the way up, what happens to the speed? What did you notice? See it? Slowing down, slowing down, slowing down, slowing down, slowing down. Right here, I'm stopped. Where am I? At the top. Then I start coming down. How could I show down on a velocity graph? Negative, 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 until it hits my hand again. Okay? So, it says, situation A, the ball has just left the hand. Right there. Where is the ball at the top? Right there. Where is the ball at the bottom? They love to ask this question and give you this graph on the provincial, and what they'll also have to pick from as the multiple choice, they'll have a graph that looks like this, because that's what most kids think it should look like. Because that's what it looks like when I throw it with my friend. Catch, Joseph. Bad toss. Back to me. Okay. They're going to think that, oh, that's what it looks like from the side. That must be what the velocity graph looks like. Actually, no. The velocity graph is a straight line. Starts positive, hits 0 at the top, goes negative, comes down. To analyze situations in free fall, we can use the accelerations that we're already familiar with. In these equations, the acceleration A is little g, or negative 9.8 meters per second squared. Okay? Can you all look up for a second? First of all, I'm going to write. I'll finish this when we see you guys next. Take a look at this sheet here. I'm not wild. I've gone on my rant. I'm purely doing this part because this seems to be how they like it on the provincial exam. So first of all, it's what's the formula for each of the following quantities. You can get those right from your formula sheet. Here it's giving you a chart. It's either going to want you to calculate the acceleration or the time or the change in velocity. What I do want to show you is it is acceptable to give acceleration in kilometers per hour squared and have your velocities in kilometers per hour. I'm just not wild about that for units, but it will work, and you'll get a time in hours, not in seconds. So you can try number 2. I'm a little more interested in stuff like number 3. I think 3A is fine, 3B is fine, 3C is fine, and 3D is fine. I'm okay with that. I'm just not fond of some of the units that they're using. I did attach the answers on the back. Again, don't be foolish and just copy the answers. That would be a silly way to do it. Give me 1 second here.